this video, we are going to go further about circle. Let's take a look at the learning outcome. So at the end of this lesson, students should be able to find the point of intersection between two circles, and also we are going to find the intersection point between a line and a circle. Second outcome, find the equation of tangent and normal to a circle. And the last one, we are going to find the length of a tangent from a point to a circle. So, to find the point of intersection between two circles, basically, we are going to do solving the simultaneous equation. So before we go further on calculation of the intersection point, so let's take a look at the type of intersection. So your circle may not intersect to each other, maybe intersect at only one point, or maybe intersect at 2 points. So we can determine this by using the discriminant b squared minus 4ac. So if your b squared minus 4ac is less than 0, mean your circle do not have the intersection point. If you calculate, you get equal to 0, it only have one intersection point, and if it is greater than 0, means your circles intersect at 2 points. Now let's look at example 13. So we are going to determine the type of intersection between two circles below. So first of all, we have to do the simultaneous equation between these two equations. Okay, let me calculate the first equation, the first circle equation. We have x minus 1 square plus y square equals to 1. Let's just expand this. So we have x squared minus 2x plus 1 plus y squared equals to 1. So simplify it, x squared minus 2x plus y squared equals to 0. So let's just name it as equation 1. Now we take the second circle equation. So we have x plus 1 square plus y square equals to 1. Expand this, we get x square plus 2x plus 1 plus y square equals to 1. Calculate, do some simple calculation. You are going to have x square plus 2x plus y square equal to 0, means our y square will be negative x square minus 2x. So I'm going to substitute this. Okay, let's name it first, second equation. So what I'm going to do next is I'm going to substitute equation 2 into equation 1. So we will have x squared minus 2x minus x squared minus 2x equals to 0. So negative 4x equal to 0. Then we get our x equals to 0. So I'm going to substitute this into equation 2. So what do I have is y square equals to 0. So means that y equals to 0. So to determine what type of intersection that this circle have, so let's calculate the discriminant based on y square equal to 0. So based on y square equal to 0, we have a equals to 1, b equals to 0, and c equals to 0. I'm going to substitute this into b square minus 4ac, which is I'm going to get 0 square minus 4 multiplied to 1 multiplied to 0. So we get exactly the value is 0. So let's do the calculation, the conclusion. Since b square minus 4ac equal to 0, therefore these two circles intersect at one point that is 0, 0. Okay, so done. Example 14. Find the point of intersection of two circles with the equation x squared plus y squared minus 3x plus 3y minus 48 equal to 0 and x squared plus y squared plus x minus 3y equal to 0. So we need to do solving simultaneous equation, but before that, let's just copy the first equation. So it is x squared plus y squared minus 3x plus 13y minus 48 equal to 0. We just name it as equation 1. And second equation, x squared plus y squared plus x minus 3y equal to 0. So this is our second equation. In my opinion, the elimination method will help us very much for this simultaneous equation solving. So let's just do the first equation minus second equation. What we are going to get is negative 4x plus 16y minus 48 equals to 0. So our 4x equals to 16y minus 48 and x equals to 4y minus 12. So let's just name this as third equation. So I decide to substitute equation 1 into equation 2. So I will have 4y minus 12 square plus y square plus 4y minus 12 minus 3y equal to 0. So expand 4y minus 12 square. So we will have 16y square minus 96y plus 144 plus y square plus 4y minus 12 minus 3y equal to 0. Calculate this, we'll get 17y square minus 95y plus 132 equal to 0. Factorize, we will get y minus 3 multiplied to 17y minus 44 equal to 0. So means we have two values of y here. So y equals to 3 and the other one y equals to 44 over 17. We will substitute these values of y into equation 3. So when y equal to 3, x equals to 4 in bracket 3 minus 12. So I get 0 here. And the other value of y, when y equals to 44 over 17. So our x will be 4 in bracket 44 over 17 minus 12. So calculation minus 28 over 17. Okay, so let's do the conclusion. Therefore, the points of intersection are 0, 3 and the other one is negative 28 over 17, 44 over 17. Okay. We are already done with finding the point of intersection between two circles. So now let's proceed to find the point of intersection of a line and a circle. So a line and a circle said not to intersect to each other if the discriminant b square minus 4ac less than 0. And if the discriminant's value equal to 0, said that that line touched the circle at only one point, and also we know it as a tangent to the circle. And the third case, if we get the value greater than 0, means now we have two intersection points. So let's just proceed to example 15. In example 15, find the intersection point between circle x square plus y square minus 6x minus 4y plus 9 equal to 0 and the line y equals to 7 minus x. So now let's just copy the equation first. We have x square plus y square minus 6x minus 4y plus 9 equal to 0. So this is our first equation. Second equation, y equals to 7 minus x. So I'm going to substitute equation 2 into equation 1. So we will have x square plus 7 minus x squared minus 6x minus 4 in bracket 7 minus x plus 9 equal to 0. Expand x squared plus 49 minus 14x plus x squared minus 6x minus 28 plus 4x plus 9 equal to 0. So we'll get 2x squared minus 16x plus 30 equals 0. Divide everything by 2. So we'll have x squared minus 8x plus 15 equal to 0. Factorize this. So x minus 3 multiplied 2, x minus 5. So now we have two values of x, which is x equals to 3 and the other one x equals to 5. Okay, so now I'm going to substitute these values into equation 2. So I have when x equal to 3, y equals to 7 minus 3, I get equal to 4. So the other one, when x equal to 5, so y equal to 7 minus 2, 7 minus 5, so I get equals to 2. So now let's conclude our answer. So therefore, the points of intersection are 3, 4, and 5, 2. So that's it. Our answer. Example 16. The equation of the circle is given by 9x squared plus y squared plus 18x minus 6y minus 26 equal to 0. So this question have two parts. Part A, find the coordinate of its center and also the radius. And part B, determine whether point 0, 4/3 lies inside or outside the circle. So let's do part A. Copy the equation. So we have 9x squared plus y squared plus 18x minus 6y minus 26 equal to 0. So let's divide every term by 9. So we are going to get x squared plus y squared plus 2x minus 2/3y minus 26/9 equal to 0. So next, what we are going to do is we are going to compare this equation with the general equation of the circle. So let's write it down. By comparing to x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So we can see that 2g equals to 2. So g equals to 1. We also get 2f equals to negative 2 over 3. So f equals to negative 1 over 3. And the last one, we need c equals to negative 26 over 9. So as we know, center is given by negative g, negative f. So our center is negative 1, 1 over 3. So we already get the coordinate of the center. So next, let's find the radius. We need to use the formula r equals to g square plus f square minus c square root. Let's substitute everything into the formula. So we have 1 square plus negative 1 over 3 square minus negative 26 over 9 and then square root. So we get the value of radius equals to 2. So let's proceed to part B. For part B, we want to determine whether the point 0, 4 over 3 lies inside or outside the circle. So what we have to do is, okay, let's start by finding the distance of point 0, 4 over 3 to center negative 1, 1 over 3. So by using this formula, distance formula, d equals to x2 minus x1 square plus y2 minus y1 square root. So doesn't matter which one will be x1, x2, y1, y2. So let's say our x2 is negative 1 minus 0 square plus 1 over 3 minus 4 over 3 square. Then we square root it. So the calculator gives us Z2. So we can see that we will compare this value d equal to Z2 with the radius that we get just now in part A. So we will conclude our answer. Since the value of d less than the value of r, so it means therefore the point 0, 4 over 3 lies inside the circle. Now we are in the final part of the circle, which is we are going to find the equation of tangent and equation of normal to a circle. So there are two methods. The first method is by using formula. So to use formula, we need at least two information here. The touch point x1, y1 and also the center of the circle. So we are going to substitute this information into this formula, which is x1 plus y1 plus g x plus x1 plus f y plus y1 plus c equal to 0. So let's proceed to second method. The second method, we use the properties of gradient. So according to the diagram, we can see that Okay, mn multiplied to mt, we get -1. Okay, mn is the gradient for normal and mt is the gradient for tangent. After we get the gradient and then the point, the touching point, we are going to substitute into this formula. So let's proceed to example 17. In example 17, find the equation of tangent and normal to a circle x squared plus y squared minus 6x minus 10y minus 82 equal to 0 at point S, -1, -5. So here we need to determine the center for the circle first. So let's just compare the equation of the circle with the general equation. So by comparing, to x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So we have 2g equals to -6, therefore g equals to -3, and 2f equals to -10, f equals to -5. So we know that the center is given by -g, -f. So our center is 3, 5. So for clearer understanding, let's sketch a simple diagram. So this is a circle with center C, 3, 5, and there's a tangent, touch the circle at point S, -1, -5. Connect this. Okay, so from here our plan is we supposed to get the gradient of normal, and then this one is our tangent, mean this the gradient of tangent. So I don't think we have problem to find the mn, the gradient for normal. So mn equals to y2 minus y1 over x2 minus x1. So we get 5 over 2. And then there's 2 points there, the center and the point S. We can use any of it to find the equation of normal. So I choose the center. So y minus y1 is 5 equals to mn 5 over 2 x minus 3. So y equals to 5 over 2x minus 5 over 2. So now we already have the equation of normal. For equation of the tangent, let's start with mn mt equals to -1. The gradient mn is 5 over 2. Mt equals to -1. So we get mt equals to -2 over 5. We don't have any other choice. We need to use the point S to find the equation of tangent. So y minus, our y1 is negative 5 equals to negative 2 over 5 x minus x1 is negative 1. So the equation is y equals to negative 2 over 5x minus 27 over 5. So this is our equation of tangent. Let's learn how to calculate the length of a tangent from a point to a circle. Consider this circle, and then this is the tangent. We have point P, and we want to find the length from point P to the touch point of the tangent. Basically, we are going to use Pythagoras theorem to find the value of D. Let's take a look. Example 18. Find the length of the tangent from point 84 to circle with center 3, 0 and radius of 2 units. So let's do some sketching first. This is the circle with center 3, 0. And then here is the tangent. Here is touch point. I name it as A. And let's say, okay, this is point 84. Just put the name as B. So if we connect everything, we will get a right angle triangle. There. So we don't have problem to find the length BC. So let's find the length BC. We will use the formula x2 minus x1 square plus y2 minus y1 square root. So we can see that 8 minus 3 square plus 4 minus 0 square root. We get the value 41 for the length. So now the length here is 41, and then the question tells us that the radius is 2 units. So let's use the Pythagoras theorem to find the value of D. D equals to 41 square minus 2 square root. So the answer is 37.
Imagine me and you, I do.